finally be going over exponential function shifts. Today's date is 6/1, which is my birthday. Happy birthday, Mr. Rothman. Exponential functions review, day 3, transformation and shifts, basics. Remember that we have our exponential function y equals a times b to the x. This is the basic exponential function. It will either look like this when b is greater than 1, or it'll look like this when b is greater than 0 and less than 1. Now we have our function that has shifts, y equals a times b to the x plus c plus d. If you've taken dense algebra with me before, we have mentioned shifts before, or transformations. And so we know when anything is added or subtracted to the outside, this d right here will move the graph up or down. We know that the a is the starting point, but now this d also impacts the starting point. B is our factor, x is our input, and this c shifts it, shifts or moves right / left, moves the graph to the right to the left, and it will still have this shape, or the shape, depending on the value of b greater than 1, b is between 1 and 0. Now let's take a look at some of these graphs. Graph the function and compare the function to the parent function. Y equals 0.25 or 1/4 to the x. Describe the transformation that occurs. Determine the domain and range for the new functions. So we have to compare these functions here to the function y equals 2 to the 0.25x. Now I'm going to go to Desmos. Y equals 0.25 to the x. Since my b value is less than 1 and greater than 0, it's going to be an exponential decay function. So this will be my first function. Now I have my second function, which is 0.25 to the x plus 3. Let's compare the two functions. So this is my parent function. So then 1, 1/4 or -1, 4. Let's take a look at this guy right here. So notice how, it got shifted up 3. Let's take a look. That would mean -1, 7. And as you can see, it only shifts it up by however much, it only shifted it up however much that was added to it. Now, this also, as you could tell, changed the range. Now this function is forever, it's not actually at 3, but it's for the rest of its function life. It's trying to get to 3 from the right side. So our parent function has the domain of all real numbers or negative infinity to infinity. The range, this function gets really big and then small, so it goes from 0, or it tries to get to 0, and it goes all the way to infinity. This is the normal exponential function. This function moves up 3, so it has the same thing as this function, except it moves up 3. And this function tries to get to 3, but it never reaches it. So that's going to be the range. So then the domain is negative infinity to infinity, and the range is from 3 to infinity, because it tries to reach 3, but it never really does. Okay, let's try comparing this graph, a parent graph, which is 0.25 to the x, 0.25 to the x plus 3, and 0.25 to the x minus 4. Now, compare our initial graph, so our parent graph, 0, 1, 0, negative 3. So it's like the same thing, except this graph right here, the minus 4 got shifted down 4. Let's test that out. So our parent graph is going to be negative 1, 4. So that means if this graph is going to be shifted down 4, it's going to be 0, negative 1, 0. And like I said, it got just shifted down 4. So it's the same graph, except it got shifted down 4 units. Let's test out negative 2. 1, 4, becomes 16 minus 4 is going to be 12. Test it out. Negative 2. Well, yep, same thing. And this guy, when this guy is negative 2. Negative 2, 16. Yep, negative 2, 16. Literally only shifted down 4 units. The domain is going to be the same. No change in the x values or the inputs. The range, to go back and take a look at the graph. This guy tries to approach negative 4, but doesn't really do so. Doesn't ever really get there. And then in terms of that, this function is big and then gets smaller. So it goes from infinity to negative 4, but it never obviously touches infinity, and it never touches negative 4. So this is up 3. This one graph goes down 4, or shifts up 3, shifts down 4. Let's test out this graph and this graph right here. Let's take a look at our parent function, our original function, which is y equals 0.25 to the x. So then let's take a look at our second function, y equals 0.25 to the x plus 2. When x, so it looks like it went 2 to the left. So when x is negative 2, y is 1, which means when x is negative 3, it'll be the same thing as the parent function when x is negative 1, because it's the same thing, except this is shifted 2 to the left. So that means it's going to be -3, 4. And there you go, right, -3, 4. So this graph is shifted to the left. The domain in range stays the same, has no impact on it. Let's take a look at this graph right here. So 0, 1. Let's see, right here is going to be 3, 1. So this graph, our last graph, has a shift to the right 3. Doesn't have it in the domain. So it looks like as far as I go left, it'll keep, grows slowly. Well, not, yeah. It goes quickly. So it looks like it has all the real numbers. So it goes all the way to the left and all the way to the right. It tries to get to 0, but never gets past it. So our domain for this guy is going to be all real numbers. So from -infinity to infinity, as with this guy, -infinity to infinity. My range would be from 0 to infinity. Same thing for this guy, from 0 to infinity. And this guy is to the left 2. This guy is to the right 3. If you have any questions, comments, or concerns, please contact me if you have any questions or concerns, either via email, via Google Classroom, via Remind. I'll